All right, fraction addition. I know this is some of your favorite topic, and I'm saying that facetiously. Fractions tend to be one of the most despised or feared topics in arithmetic, and it's important to understand how to work with fractions to do algebraic equations, especially equations involving rational numbers. Now, we've talked about rational numbers. Rational numbers are numbers that can be expressed as fractions, a ratio of two whole numbers. Let me give you an example. 1/3 plus 2/5. 1/3 plus 2/5. And now I'm going to use these squares here to represent the process of adding 1/3 and 2/5. All right. So first, let's talk about the fraction and what it means. The top number in a fraction is the numerator. It answers the question, how many? The bottom number is the denominator. It answers the question, what kind? So when we have the fraction 1/3, there are one of them, and they are thirds. They are thirds because they divide the whole into 3 equal parts. So let's divide this into approximately 3 equal parts. So I'm going to cut it twice to make thirds. All right? And I'm going to shade one of them. This represents the quantity 1/3, where 1 whole is the total square. All right, 2/5. I'm going to divide this horizontally, and I'm going to divide it evenly into fifths. And I'm going to shade 2 of them. Okay, so that represents 2/5. What kind are they? They are fifths. How many are there? There are 2 of them. Now the secret to addition comes this way, and this is going to make it apparent why I divided it vertically and horizontally. Represent each in terms of the other. So the third I'm going to divide into fifths. So I'm going to cut it into 5 equal parts. And the fifths I'm going to divide into 3 equal parts. Okay. Now let's look at what they are. What kind are they? They are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. They are 15ths. And how many are shaded? 1, 2, 3, 4, 5. So 1/3 can be represented as 5/15ths. 2/5 can be represented as 15ths again, because if you count them, there are 15. The whole is divided into 15 equal parts. How many are shaded? 1, 2, 3, 4, 5, 6. 6/15ths. So 5/15ths plus 6/15ths. Now they are 15ths. So what is the answer to the question? 5/15ths and 6/15ths are 11/15ths. Okay? All right, so that's how to do it graphically. And hopefully that will help make sense of what's going on here. But now let's do this. Let's see if we can come up with a schema or a plan to add the fractions without having to draw these diagrams. So here's the plan. 3 times 5 is 15. 5 times 1 is 5. 3 times 2 is 6. 5 plus 6 is 11. 11/15ths. So there's this pattern going on, crisscross across. Some of my students called it crisscross applesauce, right? It's a pattern that always works. It doesn't always get you the least common denominator. If you're used to getting the least common denominator, it doesn't always give you that, but you may have to do some reducing, but it's a simple pattern to remember. Okay, so let's try another here, just to be very clear, to make it clear here. And I just realized I drew on the original. Okay, so let's do this here. So 1 square represents 1 whole. And let's do another fraction here. Let's do 3/5 plus 3/4. 3/5 plus 3/4. So divide the first square into fifths, into 5 equal parts. 1, 2, 3, 4, 5. 3/5. And divide the other one into fourths. So I'm going to divide it in half, divide those in half again, and 3/4. Okay, now represent each in terms of the other. I'm going to divide the fifths into fourths. And I'm going to divide the fourths into fifths. Okay, what kind are they? They are 5/4 or 20ths. Both are divided now into 20ths. And there are 3/4 or 12 20ths. And there are 5/3 or 15 20ths. For a total of 15 plus 12, 27 20ths. Okay? Now, you may recognize that's more than one whole, right? So we can represent that as 20 20ths. Right? All 20 of them shaded. Plus 7 more 20ths. So here's 4, 5, 6, 7. So they are 1 whole and 7 20ths. Or as a mixed number, 1 and 7 20ths. Or as an improper fraction, 27 20ths. Okay, let's review how to do that using the algorithm. Crisscross, across. 5 times 4 is 20. 4 times 3 is 12. 5 times 3 is 15. 12 plus 15 is 27 20ths. 20 goes into 27 once, with 7 left over. Okay? All right. What about proving that two rational numbers add to make another rational number? That can be done this way. We represent them with variables. The ratio A over B plus C over D equals, and use the algorithm. In order to add, crisscross across, B times D, A times D, B times C, add AD plus BC. AD plus BC over VD. Now if A, B, C, and D are all integers, all positive or negative whole numbers, where the denominator can't be 0, so B or D can't be 0, does this result in a fraction? And the answer is yes. When you multiply two integers, you get another integer. When you add two integers, you get another integer. And so this is an integer over an integer. All right? One more time. Let's say prove or determine if the answer is rational or irrational. Okay? And let's do 3/5 plus 8/15. Okay? Is it rational or irrational? And the question is 3/5 rational? Yes. Is 8/15 rational? Yes. And so the answer is rational. But let's go ahead and find the answer. 5 times 15 is 75. 15 times 3 is 45. 5 times 8 is 40. 45 plus 40 is 85 over 75. Now note this is a correct answer, but it is not reduced. And so if you need to reduce it, think of a number that divides both evenly. They both end in 5, so I'm going to divide them both by 5. 5 into 8 goes once with 3 left over. 5 into 35 goes 7. 5 into 7 goes once with 2 left over. 5 into 25 goes 5. So 17/15 or 1 and 2/15. Okay? And so the answer is rational. Okay? One more time. What if you don't have fractions? What if you have 5 plus 3/8? Well, you can express 5 as a fraction by putting it over 1. 5 is the same as 5 over 1. Again, crisscross across. 8 times 1 is 8. 8 times 5 is 40. 3 times 1 is 3. 40 plus 3 is 43. So this is 43/8. 8 times 6 is 42. So there's 1 left over. 6 and 1/8 is a mixed number, or 43/8 is an improper fraction. Okay? And one more that you're going to be given that you need to be able to work with here. What if we have the square root of 16 plus 3/5? Well, the square root of 16 is a nice round number because 4 times 4 is 16. So this is simply 4 plus 3/5. And 4 can be written as 4 over 1. We can do 5 times 1 is 5. 5 times 4 is 20. 1 times 3 is 3. 20 plus 3 is 23. 23/5 is 4 and 3/5. Okay, so hopefully that helps.